Good day, sir.
Today we are going to be looking at differentiation of inverse trigonometric functions, and we are going to be looking at an examples y is equal to sine inverse of s. Now in this case, we are going to be proving it. Now when you say solution on this, you are having y is equal to sine inverse of s. This can be implied that y is equal to 1 all over sine, then s. We meant to understand that 2 raised to the power of minus 1 meaning 1 over 2. A raised to the power of minus 1 meaning 1 over a. That was what I did here. Now, in this case, we are going to say y is equal to s times 1, which is s over sine. Then cross multiply. Sine with times y will become sine y is equal to 1 times a, which is s. You can call this one maybe equation 1 to make your work more perfect. Now in this case, we are going to differentiate this. We are going to be using implicit differentiation to differentiate this. When you differentiate sine, you are going to be having cos y dy all over ds. When you differentiate s, you are going to have 1. Implicit differentiation. Now, I can divide here by cos y divided by cos y. This and this cancel. Then I left with dy with respect to s to be 1 over cos y. I can call this one equation 2. Now, before moving further, our trigonometric functions that said cos square theta plus sine square theta is equal to 1. In this case, let's make cos square theta the subject of the formula. Let's say cos square theta is equal to 1 minus sine square theta. Now, I've made cos square theta the subject of the formula. Now, then, let's say, okay, you square both sides of the cos square theta. Therefore, you're going to be having, you square both sides. If you square both sides, you're going to have cos theta is equal to the square root of 1 minus sine square theta. Now, in this, you are having cos theta is equal to square root of 1 minus sine square theta. Now, we can call this one equation 3. I can put equation 3 to this. Now that I'm making use of theta, I can change this theta to become y. Since we are working with y, I can now say cos y is equal to square root of 1 minus sine square y. Where you see theta, you replace it with y. Now in this case, I can input this into this. Now, therefore, we are going to be having dy with respect to ds to be equal to 1 over cos y. That means from our equation 2. We are having this. Now, where you see cos y, you place 1 over sine square y. Therefore, dy with respect to s is going to be 1 over square root of 1 minus sine square y. Now, from our equation 1, we have sine y to be s. Wherever you see sine y, you put s. Anywhere you see sine y, you put s. Therefore, you are going to have dy with respect to ds to be what? 1 over root 1 minus s square. Because our s here, our sine y is s, and we have the sine square y. Therefore, the s is going to be squared. Now, at the end of the day, we are going to have, therefore, y is equal to sine inverse of s is going to be what? 1 all over root 1 minus s squared. This is the answer. We have done with the what? The proving. Thank you very much. My name is Mr. Ola from Angelic Academy. Thank you. When you see someone, you